Hello there, welcome to the October 2020 paper. Here we're on the proof question, which is question 13. Part A is prove that for all values A and B, this inequality is true here. So let's get started on part A. Now what we want to do is just work on part A, rearrange the algebra a little bit until we get to a universally acknowledged fact. Like generally with inequalities, you're looking to prove that something squared is greater than or equal to 0. So let's just rearrange this to start with. So for A, let's create common denominators on this to start with. So on the first one, I need to multiply by an extra A. So that's going to turn into 4A squared on the top. And on the second one, I need to multiply the top by another B. So that'll be now B squared. Let's just rub those workings out just to not confuse things later on. This is going to be greater than or equal to 4. Now we'll add the fractions together because we have created a common denominator. Now let's multiply both sides by AB. Now that's not going to change the inequality because A and B are both positive values. So if one of them was potentially negative, that would have to flip the inequality the other way around. That's why this question here specifically states for positive values of A and B. Let's just now subtract this onto the other side. We're looking to make an inequality that is greater than or equal to 0 because always a squared inequality, a squared bracket, will always be greater than or equal to 0. And if we factorise this now, we get 2a minus b is greater than or equal to 0. So our proof is going to start with this inequality at the bottom there. As all squared values are positive or 0, we can say that 2a minus b squared is greater than or equal to 0. Now we'll just apply some mathematical logical manoeuvres. So we'll expand the brackets. 4a squared minus 4ab plus b squared is greater than or equal to 0. Let's now move that 4ab onto the other side. 4ab. Now we'll divide by the ab. Now we have to write a reason why this is allowed here, because this is allowed without affecting the inequality. Without affecting the inequality. Because A and B are positive. So let's divide by the AB. It's going to be 4a squared plus b squared over ab is greater than or equal to 4. Let's now split them up into their separate fractions. 4a squared over ab plus b squared over ab is greater than or equal to 4. Let's now simplify both of these fractions and we get our answer, which is 4a over b plus b over a is greater than or equal to 4. So there we are, that's the answer to this question. So that's the answer to part A anyway. So we have started with a fact that all squared values are positive or 0. So therefore we can say that 2a minus b is greater than or equal to 0. And then we've just applied mathematical logic to get from one fact to another fact. So there we are, that's the answer to this question. And doing part B in a small box down the bottom here, all we need to now do is to brew a counterexample. Prove by counterexample that this is not true for all values a and b. So now we're not just thinking about positive a and b, any values of a and b. So if I just set a equal to 1, b equal to minus 1, then this is not going to be true because this step here would flip the inequality the other way around. So if we do 4 times 1 over minus 1 and add minus 1 over 1, then this is going to equal minus 5, which is not bigger than 4. So there we are. Nice little counterexample is a equals 1, b equals minus 1, because that will give us minus 5, which is not bigger than 4. So there we are. This is the answer for this question here. So this work here might get you a few marks, but the proof really comes in stating your proof in this box here. This is the answer to this question. So there we are, that's the answer for question 13. They're worth 5 marks in total. Let's now move on to the final question, question 14.